Yes, I can. Okay, perfect. Just give me a second. Yes, please. Yeah. Thank you, Namish, for that. So I'll just take it from here, I guess. So first of all, thank you all for joining the session. And I know it's pretty late in India, but yeah, unfortunately, that's how it is. So I'll just try to share my screen and let me know if you can see it. So I'll just try to fix it. Let me know what you see. Okay, perfect. I'm just gonna slide it to see if the slide also moves. Okay, perfect. Yeah, so I'll just begin the session. So I think Namish had approached me to give a very small session regarding what he called what are the job prospects that's happening within the field of EEE electrical engineering, and also I just run through some of the things, and also like what I was just thinking is once I did make a similar slides back in December, like while I was at MEC, while I was in the college. So I just thought I'll just make some improvisation on that to run through the different things that's happening in the world of EEE, and then I think we can have some interesting Q&A session. So feel free to ask. And if at all of you feel that you don't have a question right now and want to reach out to me privately, that's also fine. We could use platform like LinkedIn to discuss on these things. And also, before I just begin, I just want to know if there is anybody in the audience who does not understand a word of Malayalam. If you understand Malayalam, it would be fine. Like if I can just have a mix of both Malayalam and English, if that's fine. Does anybody have an objection to that? I would take that as a no. All right, I'll just go through it. So I think I'll just introduce myself, although Namish gave me. So I'll just keep it very simple. So yes, my name is Arvind. I hail from Kerala. So my place is Kakinad. Currently, I'm working as a technical lead in Vestas. So I'm looking into the what you call the electrical system design in Vestas. So you can say that I'm a electrical engineer who's basically designing the wind turbine. So that is basically my day-to-day part of the life. And I'm located in Copenhagen in Denmark. And yes, so close to around 10 to 11 plus years of experience working in different areas like power systems, lightning protection. So that's basically I was. And also you can just see I'm a graduate from EEE, class of 2014. So we were the second batch of EEE that just graduated. The first was in 2013. I also have my master's from Aalborg University in Denmark. So I did that like 2 years ago, where I specialized in power systems. There are also a couple of awards, and also I do have a few patents within EU and US, mostly related to wind turbine design, electrical systems. And I have been working in different companies. Like after I graduated, I worked with electrical contractor in Mumbai for almost a year. I was working within a KCB substation. Later, I moved to KCB, then Schneider in Bangalore, Siemens in Bangalore, and then finally Vestas in Denmark. Here I am. Uh, Before we look at some of the opportunities or like what are the best ways like you can get a job, it's very important that I just want to highlight some of the important projects that's happening across the world of electrical engineering, because it's important to give you a perspective on what is actually happening, or maybe one of you who would be like attending the session would be like working on these projects in the future. So let's look at some of the things, especially like when you look at electrical, the most important or the debatable topic is always the renewable energy. So that just this is a graph that actually shows a massive ramping up of the renewable energy projects that's happening across the globe. So we have a data till 2025, and you can see how the graph has just ramped up exponentially from 2010. There are a lot of things happening: offshore wind, onshore wind, large scale solar power plants, geothermal, hydro. Everything is booming. So literally, there is a massive opportunity. So this is still 2025, but this just keeps on increasing because the electricity demand is so high. This is throughout the world, which also includes India. So let me actually take you to some real life projects. So one on the top is some of the projects that's called the Baltic Power, and on the right hand side is a big wind farm which is called the Dogger Bank. So it will be commissioned in 2026, and that will be the largest wind farm in the world. That's like 3,600 megawatt purely through wind. So you can see how much of a contribution this is making towards green electricity. And if I say 3,600 megawatts, will be try to put from a perspective that we understand. If people know Idikki's Moolamatam hydroelectric project, it's just 780 megawatts. This is 3,600. So 5 times the size of Moolamatam is what you see in this wind power plant. Of course, it's in the power capacity, but not consuming a large area. You don't have to build a dam, but purely from the source of wind. You also have massive solar-based projects also that's coming across. So on the left-hand side, you can see that's the Mohammed bin Rashid project in Dubai, a massive solar power plant that's coming in the region of Dubai in UAE. And on the right-hand side, that's a new solar project that's coming in Spain. So you can see there's a solar panel project, and also the one on the left, the one in Dubai, that's a solar mirror-based project. Massive projects, different technology, but completely with the use of renewables. So it just doesn't end there. You have big projects like Energy Islands in Denmark, which are massive renewable energy interconnection project, which are solar, wind, bio, ammonia, and also hydrogen. So it's a massive renewable energy project that's connecting different parts of Europe. We have something called an energy island in Belgium, and massive projects towards power to X, power to hydrogen that's happening across Europe and US. A new technology is also there, maybe like it's called the nuclear fusion. So just to give a perspective, like the one that you have in Chennai, that's a nuclear fusion, but nuclear fusion is a new technology. Indian government was part of this project in France, and also we do have some startups. There are many startups across Europe and US working on such projects, but there is a lot of investment, there is a lot of research that's going on towards such massive new ways of technology, new ways of producing electricity without affecting our planet. Energy storage is a very big hot topic that we are being discussed these days. So when I mean energy storage, it's very common that people think about batteries, but that's just not the case. You can have hydrogen storage, capacitor storage, superconducting magnetic energy storage. So different storage solutions are also emerging in the field of electrical engineering. India is not at all behind in any of these energy ecosystem. So very recently, if you have seen the news, the Ministry of Power just signed a contract between UAE and Saudi Arabia, where we will have a massive power transmission link connecting India, UAE, Saudi Arabia, and I think it's all the way till Israel. So it's a massive project, massive transmission project. Same also goes towards the ASEAN side, where India is planning to support electricity, transmit electricity towards these regions that you see in the Southeast Asian regions. So the plan is to make India like a major energy center because of certain geopolitical tensions between China. Most of the countries are like kind of interested in looking towards India as a major energy hub. So what this means is that there is a ample amount of opportunity that you're seeing within the country like India. So huge potential is like building up. One best example I want to take is the Kavda project in Rajasthan, very recently signed. So this is another massive solar project that's being built in Rajasthan, which will have like I don't recall the exact capacity of megawatts, but it's a massive project with a lot of high voltage direct current mega project. It's involved different people like Adani and also Hitachi Energy. So massive projects are also happening within India to so show that like we are in the path towards a complete fossil-free future. Now let us. I just wanted to give that revamp to most of you to get an idea that there is a massive scope. So that is the important point that I want to communicate. So when you take a course like EEE and look at like what would I be doing, like let's say 5 or 10 years from now, it could be one of these projects. There are multiple projects. You can also just Google it. But like if you look at, there are multiple projects that's happening across the world where there is like a lot of opportunities for young engineers like you. And I believe that people like you should be part of it, contribute towards the greener world. Now, if you ask the question to me, like what is the best and the fastest way, I think that's why most of the people here the session have joined. Like, what is the best way that I can just secure a job? Let's say an electrical core job by the time I graduate. My simple answer would be a campus placement. And of course, MEC has a good record with a lot of companies coming in, and as long as you have some sort of a good academic record, you are active in different, let's say, events like Excel, part of the Electricity Minds Forum Club, and other extracurricular activities, there is a good opportunity that you get placed, and otherwise also. But the most important thing, like I said, what is of if someone asks me this question, like see, like I'm the final year student in MBC, and what is the easiest or the fastest way to secure a job, I would still have to say campus placement. But it does comes with certain what you call limitations, because if I look at here, there is a tons of companies that you can see in the list. But if I just sort of filter the electrical core companies that have come in the last couple of years, then it kind of reduces to a smaller number. Of course, I have not listed everything here, but I just wanted to highlight these two companies because I'm kind of associated with them in the past. So it's very important to know that when you look at electrical core companies that come to the campus, it's limited. And one of the reasons is that the amount of job that they can generate for young students is kind of limited compared to, let's say, a service-based company like TCS or Wipro or some Sutherland. So it's limited. But though that's a drawback, but if you can somehow sort of ensure that you get placed in some of these companies, I think this is a good start. And that's the easiest start, because the placement cell would just help you to reach these companies. They bring the company, you don't have to worry about it. It's just about you and your performance on how you sort of attend it. Now, this is one thing which I wanted to cover last time, but I'm going to use this. Now, what I sort of think is each one of us has some different sort of talent or some sort of skill. And it's very important to understand what sort of category we belong. Each one of us is different. So, I don't know, maybe the strength of the triple is like around, I don't know, 40, 50, up to 70, I guess. But each of you individual are different from each other. Some of you have different skill set, some of them have certain weaker points but a different skill set. So it's important to understand where you belong. It's just a tip, but just kind of see if this works out. So I put classified generally people into three categories, like category A, B, C. So the category A is basically the one that is some students who have like strong technical foundation, someone who's always in the top five when it comes to marks. So you look at your marks of the grades till essay. If you are in a consistent mark performance till essay, so you are the one who belong to the category A. You have a consistent track record. You have a consistent academic performance. You have whether you it doesn't matter what method you use, whether you mug up or whether you sort of understand an answer. You are in category A. You have, and that's a skill set, that's a skill set that need to be appreciated, because everyone cannot do that. Everyone cannot be in a consistent top five through the course of 8 semesters. So that's a skill set. Now the next category is category B. So this sort of people are the ones who are good in academics, but you're not the topper kind of thing. You are not in the top five. Maybe you could be in the top 10 or even the top 20, but you are good in academics. You do not have a track record of arrears. You manage to clear the exam, but at the same time you do have certain features, like you are active, let's say in the Excel, you are in the core committee, you could be part of EMF and organizing events, you could have other extracurricular activities, maybe like arts, volleyball, basketball. You would have some sort of talent as well besides studies. So I would picturize and these kind of students as someone who's like sort of an all-rounder. You're good at academics and you do have some sort of extracurricular activities, and it kind of balances. So I would call some sort of an all-rounder kind of category is what I call category B. And then there is people like me, which is category C. So I have to specifically put myself here because I would have been in a category B, because uh, due to my own reasons, due to my own things of not studying, it's not an excuse. I did not study properly. That basically pulled me down the academic ranking. So I was like not a good studying student, and that's completely my fault. But at the same time, like I just ensured that okay, I had to have some sort of skill. So there are people, if you look at in your class also, who may not be like so good at studies. Maybe they don't showcase good marks. They may have some sort of arrears or backlogs, but there are certain other skill sets that you people have which others don't have. So let me just try to give a perspective. Like when I say that I wasn't good in academics, but I was good at something. So just to give my perspective, I have to say that I was good at building things. So this is an example of what we call a Tesla coil. So the one who's sitting on the right corner is me. So we built this project, or I had a skill to build something which most of us couldn't do, or most of us were not willing to do because of the challenge that is involved. So this was what I would say my skill. So we did not do this as part of some sort of a what you call Excel or EMF or anything. It was just out of the random. So I was able to form a team. I was able to drive that passion to the same team with all the seven of us working together and building something that others have done. And mind you, this is one of the uh, first ever Tesla coil that is made in the state of Kerala, and we ensure that these things go noticed. So Madhurumi began to cover, and also same came with Times of India to ensure that okay, such massive projects are happening or students are doing something that is beyond the curriculum. So I ensure that these things happen, and also by the time we graduate, we are the team that makes the most noise. So what I'm trying to say is that like people in category C, like you would have some sort of a different skill set, and that should be your asset. And I'll just try to combine what does picturizing yourself in different categories mean and how can we target or to secure jobs in electrical core areas. So one thing I just want to highlight is think about government jobs. And this specifically I would say to people who think that they belong to category A and category B. So like I said, people who have a strong track record of getting into good marks, good academic records, and you have a skill set of scoring marks somehow. And let's say that it could be that you have a good memory power, it could be that you have good attitude skills, but it doesn't matter. You have a skill set to write or be part of a competitive exam, secure good marks, and that's a skill set. And people like that, I would say that this is an opportunity. Aim for government jobs. We have like different departments across the government of India and also the state government, where you can actually see good opportunities. Be it the Indian Railways, be it the Kerala State Electricity Board, you could be in DRDO. It could also be the Power Grid Corporation. So there is a ample amount of opportunity that awaits people. So most of the time when we look at getting easy job, there's a tendency that we tend to forget there are much beautiful jobs in the field of central government. So think about this for the people who are the third year. I think third years are also part of it, and also fourth year. So think about it within a year or 2 years, like you're going to get graduate, and think about this opportunity. Like, is central government worth it? Is something that I can give a try? Because without much further explanation, you already know that what is the opportunity that awaits when you get in or land into some electrical core jobs that's in the field of central government. Now, for those people, like I said, central government is not everyone's cup of tea. You need to have some intense preparation to get into the jobs. But let's look at some other opportunities when you are not so passionate about, let's say, the central government or getting something into the government. So this is where the graduate programs open. And of course, like third years and fourth years, like you would be like graduating soon. It's well obvious that you do not have much prior experience. So that is exactly why these companies have tailored graduate programs. So I would just say that this is a list of few companies. There are many companies in India, and most of these companies are international, and they all have offices in India. And the reason why they have offices in India is an advantage for young graduates like you, because you can apply for these graduate program. So I think just to give a reminder, the 2025 graduate program is already closed, but the 2026 graduate program would begin, and the process for that would usually begin somewhere around December, or from October to December of 2025. So you will have certain screening processes, and the application would begin somewhat during this stage. And this sort of applies to most of the companies. So be it the Siemens Energy, Vestas, ABB, they all have their graduate program beginning somewhere in this region. So the 2026 graduate program, have a thought, it would begin, the application process would begin before the end of this year, somewhere around October, November, December of 2025. Now, this is something that I want to show, because when you look at because this is something that I just adopted from MAC, where you have like different sort of what do you call companies that's a part of the core electrical campaign. And if you look at it, there are like, I don't think the slide is just enough for me to fill all the core electrical companies. So you have companies that build power projects. You have companies like Vestas, which build wind turbine generators. There are companies like Schneider Electric, which build other electrical systems. So if you look at this, there's a huge amount of opportunity or huge number of companies which are outside, and also they have offices in India, which I would say is a big opportunity for new graduates, like who's coming or graduating in 1 or 2 years. So it's a big opportunity outside, and the major thing is, how do we get into it? And I just want you to picturize this image. And of course, like I said, I did not include every company, but think that one of your dream company is actually in this, one of your dream companies. So just to give my perspective, my dream company while I was working as a third year was to work in ABB. And to reach ABB, like while I was a third year and fourth year, I just had to ask these few questions. I think you could also picture it, be it central government, be it some private company. Just have a question like, what is my dream company and how do I reach my dream company? Have a plan for that. Where to start is an important question, because the area where you start basically drives your whole future. And how to start, like I said, in a company there are different divisions, so you need to sort of think where or how to start in that. What sort of position should I start? Should I start like a graduate engineer? Should I start like an intern? Should I start like an apprentice? So different options are there, so you need to think like, what is the best option for me to start and when to start. Of course, in your case, it would be right after graduation, but it doesn't matter. You could maybe begin your internship. If you get an internship opportunity before you graduate, that's absolutely fine. So the question is about looking at more of opportunity and thinking about what is the right place, where to start, how to start, and when to start. So let me just give my perspective, like the boy on the image, that's basically me, I would just say. So I wanted to work in ABB, like I said, and that's to the power transformers and the switchgears. This is what I knew back then in 2014, and I wanted to reach ABB. But just imagine my level versus ABB. It's too far. It's very difficult for me to reach. So my approach was that I just put these questions toward me: where to start, how to start, and when to start. And my approach was to start small. And again, I had to start small. If you recall, it's because I was in a kind of category C, because I did not have good academics, so my opportunities were diminished. I was not, again, like not good at problem solving and then clearing government exams. So even central government or the state government exams were out of option for me. So I am limited in option. So the only option I could try was to begin something small. And what I did is I started with KCB. And again, to be precise, like I started as a worker in KCB, doing maintenance work and stuff like that. And slowly, 2 years, I started working in KCB, building my CV, trying to understand about substations, transformers, and different power system components. And then I got my first breakthrough at Schneider. It took me 2 years to build a CV, and within the two, it just doesn't mean like I was waiting for the whole 2 years. Continuously, while I was working in KCB, I was trying to build my CV, looking for opportunities in Naukri.com and LinkedIn, trying to connect with some of my friends and see like where is opportunity. Eventually, the opportunity came. So just see, like one of my friends just suggested that, okay, he heard from one of his friends that there's an opportunity in Schneider and they wanted someone with a 2 or 3 year background. See, so while I was searching, this came in and I got this opportunity. And within this 2 years, I would say that I don't recall how many applications I had applied, and there were a lot of applications, and all of them got rejected. There was not a single job that I landed, and the first job I landed was Schneider. So just imagine, I just got the one of the best jobs which I can land based on the skills and availability and whatever opportunities I had. From Schneider, things started going up. So again, you went into a corporate environment, you started working with complete latest electrical products. You start building network, and then I got the opportunity to work with Siemens Gamesa, and that's when I started entering into the world of wind domain. Just imagine, I still haven't reached my target ABB. The only thing right now is I haven't reached ABB, but it's a different alternate path that I have taken. So right now I can say that I have reached a company where I'm working in a domain. I build wind turbines. I build the electrical systems for the wind turbines. So I can clearly and proudly say that I have reached a level where I'm working in a job that I like. So this is the path that I have chosen, and I'm not saying this shall be the path everybody should take. I'm just giving an example. So for someone who writes the central government in the first attempt and then you clear it, you don't have to go through this. You have already secured yourself in a good path. For someone who gets a campus placement in TNEI or Calki Tech, you need not go through this path. You have already landed there. For someone who enters through the graduate program, it's the same thing. You just have entered, you have just opened your door instantly through the world of electrical engineering. So look for opportunities. Everything is an opportunity. So look at that in a positive way. For some people, for me, for a person like me, it took 2 years to get into a core company. So that doesn't mean it would take 2 years for everyone. It could be 2 months. It could be 6 months for someone. Maybe it could be 5 years. But it is waiting for the right opportunity. You have to look for it continuously. Look for the right opportunity. One of the doors will knock, and that's where you begin. Now, one of the important points which also I want to add here is the master's program, and I think this is very important because it's a trend. Because most of the people sort of look at master's program as one of the best way to escape. I mean, look out of India. Let's not use the word escape, but look outside as an opportunity, India and outside of India, and like at a possibility where you are not getting a job, and foreign country is the best place where you can actually land in a job. Before anyone goes to that, I have a simple suggestion. Again, it's a suggestion. This is not to enforce. I would just ask anybody who's going for a master's program outside, especially you as a graduate. Imagine within the 4 years, like you are going to be a graduate in a year, you do not have any prior experience. You are going to a master's program in a different country, and have in mind that you are not the only person coming to that university or to that country. So have these questions in your mind. Is it actually worth going to a new place? Is it the right university to study? Because it's very important, because if you look at the university, I think for those people who are part of the masters aspirants, you would be looking at rankings like QS ranking. It's very important to assess that whatever course you're studying, that university is well ranked. It shall be at least within the rank 100 in QS, and not the university, the department. That's very important, because you could be going to university which has a good ranking, maybe due to the mechanical department or due to computer science department, but the same university with a good rank can have a bad electrical engineering department, so it doesn't make sense for you to go to that department. So be very clear and be very cautious when you choose a university. How well is a department, and that's something for you to investigate. The third question is, whatever you're studying, be it machine learning, you want to do some sort of data analytics or core power systems, what is that you can not learn in India, and what is that exclusivity part that you get from country abroad? So when you say something like global exposure or something that I'm getting, think about it. Most likely you're going to end up in a university where there are again a lot of Indians. So it's like you are meeting again Indians in a different country. So that is not global exposure. So be very clear when you put some aims on why you want to go to a different country. What is that you are going to get in that university in that country, which is not there in India. India has some brilliant institutions where you can do master. So have that in mind. But if you have an answer, like there is something specific to this university which only this university or this country can provide, then you have an answer. And fourth is the most important question: how big is the job market for international? So kindly understand that you, me, we are all internationals in a different country when you go outside India. So there are Indians, there are Pakistanis, Sri Lankans, Chinese, Iranians, then people coming from other European countries also. So when you look at the job market, it is important to understand how the job market is for international, because your aim to do a master's in a different country is to land in an electrical core job, right? So it is important for you to assess. You could look up in LinkedIn, if just search for an electrical engineer job in, let's say, Germany, and see how much of them sort of filter, or how much of them actually invite graduates or someone who just finished their master. So you get an understanding what is actually the job market. So choose a country where there is ample amount of job market. Germany is a good option. UK is a good option. Denmark, I would say, is an average or a below average option for it, because it's a very small country. Job market is lower. So personally, I would not recommend unless you have like specific reason to come to Denmark. So just give a perspective. US is a country that has a great job market for international. So think about the countries, think about the universities where you want to go, and where you think that you will have a security in terms of getting a job. Now, those are some of the practical things that I just want you to have a revamp. And I think I just want to add some points, like few tips for the third and fourth years, because especially the 4th years. And the reason why I added this slide was when I spoke to Namish, he said that like the topics regarding their main projects is under discussion. Some sort of brainstorming is happening, and if I'm not late into giving this sort of advice, just sort of give it. Otherwise, just ignore it. So one important thing is main project is the core thing. So in terms of your final year, and this makes you stand out when you are entering into an interview with a core company. Imagine like you are sitting in an interview for Caltech or IPS or even Vestas. So of course there are a lot of things that would be common, and since you're a graduate, there would be not much to write in your CV. So we know that it will be limited, but what sort of stands out is your main project. And also when it comes to building a solid CV, I would just say, I would say make a CV good. And CV basically represents you, your character, because it's a piece of paper that basically shows you. So I'm not going to say or give any advice that the CV shall be 2 page long. It's wrong. The CV shall be short enough. It should be concise. No, I am not going to give any advice to that. The reason for that is basically CV represents you. You are the one who's being represented in that piece of paper. So when someone reads it, they should feel impressive. So doesn't matter how you build a CV. This is my approach. It doesn't matter how you build a CV. You are being represented in that piece of paper. So have a respect towards that. Ensure that that sort of brings some value, something that's kind of attractive in a professional sense. So that's what I would say. I would not comment on what shall be the content. That's completely up to you. It can vary from person to person. The way I make a CV could be different. Again, coming back to the part of project, because ensure that again, I have to stress this point, because this is the area where you would finally apply all your in the 4 years of engineering, all those mathematics calculation, differential equations, and all those things, like what you learned, it is the final place where you actually apply. And that is one of the reasons why I'm still stressing, because in your CV what sort of stands out is basically this project. And it's a very common thing in the interview where people ask, of course they're going to ask about how about your college life, what sort of roles you did, and about your academics. But this sort of shows what is the level of understanding that, or what is the level of engineering principles that you sort of utilized from your 4 years and put into practice. So that is the reason, keep always in mind that the project that you do is very important. And my humble request, kindly do not, I mean, at least it was a thing back in our days, like people just used to outsource this project to certain companies or some lab and they just bill for it. So my recommendation, do on your own. That shows some sort of credibility. That even if it's a small project, be genuine, be credible to that. Show some justice that you did engineering, and rather than doing or giving it to someone else. Now, some tips about projects, and like I said, I just want to highlight some points specifically regarding the choice of what do you call the main project that you would be executing in a 1 month time. So I understand from the syllabus that this semester the S7 would be working on some theme, but mostly it's the S8 where you're actually implementing the project. So I just want you to look at the slide where on the left hand side, that's an example of a vertical axis wind turbine. And the right hand side, you can see something that's made in MATLAB, right? So I just want to give you certain do's and don'ts. Again, it's not something that I'm going to impose or I would be forcing on. You have a perspective, have a thought about it. Now, in my opinion, strictly speaking, as someone who's working from 11 years in power industry, I would recommend that not doing a prototype. Now, the reason for that is you have a look at a vertical axis wind turbine and just tell me what is electrical about what you see there. There is absolutely nothing electrical about that particular prototype that you see on the screen, because anybody, any technician can build it. That's not exactly what an engineer does. Because if you enter into a engineering job, let's say that you are working in a company like Vestas, or you are part of an engineering team who builds wind turbine, and you as an electrical engineer, most of the time you would be working in some tools such as MATLAB, or there are Power Factory, PSCAD. So there are certain specific tools a company use. But let me give you an example of a software that is available in the college. You would work as an electrical engineer building models, building concepts in MATLAB, trying to improvise these designs, thinking, okay, what would happen if I change this parameter? How does that affect the design of the wind turbine? How was this going to, if I decrease something, what does that mean for the wind turbine? Will the wind turbine even work? So these are the things that you would do as an engineer in a wind domain. So this is some, and to know that, to understand the behavior of different parameters, to come up with different engineering concepts, important that you work with softwares. And that is the reason why I'm still stressing, if there is an opportunity to execute a project in MATLAB, use that, and only build a prototype like what you see on the left if it's like really necessary. And again, like just to give a perspective, I did meet one of the students from Model Engineering College who made a vertical axis wind turbine. So it was a bit late, and he said that he wanted to build a vertical axis wind turbine. And I asked, what is the project about it? So he said, we are building it, a physical prototype, and then we are going to light a bulb. So if you call that a main project, for me that's a 8th standard science fair project. You build a vertical axis wind turbine and it's connected to light bulb. It just doesn't make any sense. Any 8th standard student can build it, and that is not what you do as an engineer. Kindly think about it. You as an engineer will build electrical models, electrical circuits, and it need not be a physical one. Use tools, because the engineering style trend has completely transformed. You will be working, like I said, in software. You cannot just uh, build a substation. I mean, you don't do that. You build substation in models. You build substation in softwares. You run different simulations. You see like what should be the sizing of the cables, what should be the clearance between the cables, what sort of transformer sizing I need, what shall be the power that is being evacuated, and what happens when some faults occur in substation. All these things are part of the engineering designs, engineering principles, and you do that in software. So kindly picture yourself what you would be doing, and that's where softwares play a crucial role. And when you look at a project, a main project, think about using such softwares. Many of you would also be big fans of EED. So again, the same thing. Look at, do not spend your time building a prototype. Just have a look at it. The wheels, the structures, the chassis, they're all mechanical. There is nothing electrical to do into it. But on the right hand side, you can actually see a MATLAB model where they have built an electrical drivetrain, evaluating like what is the impact of the motor, how does the armature current sort of varies. You can build a project as a final year project, thinking about build an electrical drivetrain. Choose like, should I go for an AC motor or a DC motor? You can work on power electronic control. What happens if I switch the frequency from 2 kilohertz to 4.7? What does that mean for my electrical drivetrain? What shall be the battery management system? How can I have a improved battery management system? How can I work on the charging, discharging efficiencies? And look at those graphs that you see here. So these are the outcomes of the project, outcomes of an engineering discipline. You kind of build a project, you understand. So when someone asks, okay, what happens when you change the coil? What happens if you choose a different cable? This is what an engineer answers. And this is what you will be doing in the future. Just picturize yourself like you are working in an electric vehicle company. You are working, let's say Mercedes-Benz hires you. You are not going to work on a, you're not going to build a prototype. That will be the mechanical engineers who will do it. You would be working on softwares like MATLAB. Maybe Benz has their own software, but you would be working on electrical models, defining the concept. Should I, like I said, should I, what sort of motor shall I use? What sort of power electronic materials shall I use? What is their electrical characteristics? What sort of cabling we need? How big shall be the batteries? Should I go for like a 4 rack, 8 rack, 12 rack, or something else? These are the things that you work as a concept. You run simulations, then you come up with a detailed design, preliminary design, and then you build this in a 3D model. This is the concept, and that's what engineers does. Same also goes with if you want to work on the renewable. So again, I'm recommending, do not go for a prototype like what you see on the left. Do not build that solar panel, because you are not going to learn anything as an engineer from it. But look at the one on the right hand side. You see what happens if you build a solar farm and you connect to the grid. Many people have a question like, why don't we just build tons of solar farm or wind farm and just basically solve and save the planet? You cannot do that. And answer that question. What is the issue with the solar? What is the problem with wind? If I cannot do that, what is the electrical challenge? So that shall be an outcome of your project. These graphs that you represent, these are the studies that show, see different test cases that run, and these graphs represent, you will understand what is the challenge with solar, what is the challenge with using renewables into the grid, and why we cannot have 100% renewable is something that you need to come out as a project, come that as a study, and come up with something where you can say that, okay, some of the future suggestions could be so and so. This is what an engineering project shall summarize. And one big advantage is, imagine with these sort of MATLAB based simulation or software based simulation, you will have a different perspective of electrical engineering altogether. You will understand different concepts. And when you sit in an interview, there is a big difference when you say that I made a MATLAB model where we evaluated different phenomena in the power system when you use a solar wind farm. This was a ZEISS, it was a 10 megawatt or a 20 megawatt solar farm. When you present that versus when you use something like a four solar panel, I just connected with a battery and then lit a bulb, there is a huge difference. On the one on the left is something that anyone with a degree lesser than engineering can do, and one on the right is what specifically an engineer does. So the level of confidence that you have, the level of pride that you have when you sit in an interview will be completely different. I'm telling, like, when you look at such projects, your perspective of engineering will change. You will learn a lot of things, and you will learn that the project just did not conclude. There is tons to learn, and that is the beauty of engineering. And that's how we work together in a team to come up with some solutions. So I had to, like I said, these are suggestions or recommendations. If you already have something in the mind, I'm not gonna complain about it, or I'm gonna say that's a bad idea. But if you have still some time, think more from a software perspective. Think more from how do I use MATLAB to build such things? How do I understand more from an engineering perspective? And with that, I would just try to conclude and sort of go through the Q&A session then. Yeah, Namish, if you want to take over. You can also speak in Malayalam if you want, that's fine. Yeah, then I'll just run through that. I think one of you had, no, did someone say something, or shall I just run through this? Yeah, okay. So someone had asked a question like, is it possible to get placed in core companies without much coding knowledge? So answer is partly yes, partly no. So definitely you do not need ample coding knowledge, like, because you are not working in a computer science field or software field. But a minimum requirement, that's a trend these days, is that you need to have a knowledge about tools like MATLAB. That's very important. So especially like if that's a tool that's available, get used to that. And one best opportunity which I'm seeing for you to use it, try to use it in your main project. Be familiarized with such tools, because MATLAB can do wonderful things. And even till date in my company, like Investors, for many things we use MATLAB. There will be a bit of coding that happens in MATLAB, but it's not very difficult. It's not very difficult. You would also need to learn a bit of Python, but it's not mandatory. It's kind of in most of the job applications I've seen, if you know or have knowledge about C++ or Python, that's an advantage. And why that is a requirement is because you do a lot of automation. Like I said, you're dealing with a lot of data. I mean, lot of data. So you play around, because I cannot give much specifics into the project, but just to give you a perspective, I am working in a project where lightning strikes on the wind turbine, and that's a big problem for us. Now we are working on a project where we are using machine learning to sort of identify where in the blade or where in the wind turbine will the lightning strike. So there is a lot of Python involved. There is a lot of understanding of how to use data analytics. So we are collecting data, a lot of filtering. We use MATLAB. So I wouldn't say you need to have an extensive coding knowledge, but have some basic coding literacy. I'm not saying you need to be an expert. As an electrical engineer, have some basic coding literacy. So you could just go through. I could see like some of the students from I think your former seniors. They were like posting in LinkedIn about some Python challenge and stuff like that. So try to execute such things in the time. Try to learn a bit about Python. So it need not be in a situation like, oh, I have no idea about Python. I have no idea about MATLAB. Let's not be that way. Yeah. I think I have a question from Anna. Let me just put here. So it said, so Anna asks, sir, as you said, it'll be good to learn MATLAB. Can you please set some resources, something we can use to learn MATLAB? So first question I would have is like, do you use MATLAB here in the what do you call it? In college? Because we used to have MATLAB. What about someone from the class can tell me? Okay. So we have MATLAB in S6. So if you ask how to use MATLAB, I think I can give some recommendations. I think I can share some link towards like how we can do it, and also what I could do is share some sort of project. So if you tell me like a theme, like I want to work on a project in, let's say, EV is a theme, and within EV, like you can have like different topics, like I said, power electronics, battery management system. You can do something on fault identification, electrical faults identification in EV. Those are projects. So if you have some specific themes, I could just recommend some resources within MATLAB where you can actually see how things are being built. So for a bachelor's project, you need not make very complex, make a simple model and then sort of evaluate from a bachelor's perspective. So as a bachelor, nobody expects you to make a pitch perfect model. The idea is to use software, see how well you build it. That's it. So yes, and I can just give you some recommendations. Yeah, that's doable. Okay. Namish, would it be possible to please in the chat? That's too much of a big question. In the meantime, when that question has been posted, I'll just continue with the question number two, which is various career opportunities after BTech. So just like I said, as I went through, you have government job opportunities, graduate program is like one another opportunity, and the other is if you do not find any of these, think of try to start small because that's the only option, but that doesn't mean you need not apply for larger companies, but maybe that's a good start. Like it kind of worked for me because like I said, I wanted to join ABB, but I need to know my level. Like I'm a graduate, I have no prior experience, so there is no reason for ABB to hire me. So what I did is I just applied a different technique where I just started small. So what I did is I started inquiring like different electrical contracting firms within Ernakulam. And then fortunately, like one of my schoolmates just popped in, and his uncle was the one who was running a contracting firm in Movatuda. So I then approached him and said, I just finished my graduation, but I wanted to learn something from your side as an experience. So he hired me. So he hired me as a worker, and I was getting paid like rupees 300 per day. So for almost 1 year, I was literally a worker in different substations and power stations. So I happened to visit inside Moolamatham. We have worked in the maintenance. So I think I worked around 77 sites, different substations and power stations of KSCB within that 2 year timeline. So like I said, I was building the CV, but for the 2 years I was working in a company that is very much localized. So I was working in a company within Ernakulam, within a very small district, but working across substations, gathering the experience, trying to build a strong CV, and at the same time looking for opportunities outside. Like I was like looking like where do I have some opportunity in like company like Siemens, ABB, continuously looking at their job portals, seeing if there's some opportunity, and that kind of worked. So I think there are different opportunities, and just I would just say that there is no perfect cookbook. So whatever opportunity comes in front of you, if you feel that is a right, go for it. Yeah, I think I'll just go to one question which Namish had mentioned. How should I start? What skills should I learn, and what projects and collabs should I do to get placed in electrical core company? So, like I said, if you, I'm not fully aware how the project setup goes, and like if there is an opportunity to collaborate with a company, even if you have an opportunity or not, what I'm trying to say is the company would, like I said, if it's a company, it's for sure they are not going to be interested in anyone building a prototype. For example, if you work in a company, like I mean, you get an opportunity. If you're interested in working in Vestas, what Vestas would be interested is what did you learn out of engineering, which is a major thing called project. And in project, if you it's advantageous when you say that I build a wind turbine model where we particularly in using MATLAB, where we particularly focused on power electronic control systems. We used IGBTs, and this is the model that we did. And what we understood is that IGBT switching behavior can affect the grid phenomena. When you have fault in the grid, this is how my wind turbine behaves. These things are very important, and Vestas would be really interested and curious to know more about your project. And of course, you will have some decent amount of knowledge because you used tools like MATLAB to understand the different phenomena, different engineering practices that's being used in the design. So these things add value. And now that's something that you do in the college, and whether we like it or not, we have to build a project. Now, on top of it, if you want to add something, you can do certification courses also. Like in Udemy, there are certain certification courses to understand about how do you perform certain what do you call short circuit calculations. There are courses on tools like ETAP, AutoCAD, and outside there is an institute in Kalur called SMEC Labs. I heard like last time they had come for some sort of a presentation. So industrial automation is a major thing. So you could do courses in the meantime on PLC, SCADA, which are like super relevant in the industry. So of course your engineering, your academics, your project, that's on one thing, and add certain certifications that add value. Like I said, automation could be one thing, PLC, SCADA programming, all those things. You could go for AutoCAD. You could try to see if you can get some certification in tools such as something that is related to EV, or tools such as Power Factory, which is very relevant if you like to work in renewable energy background, if you want to work in wind, solar, renewables, and especially if you want to see yourself as a power system engineer, like how do I model a power system, then these softwares are very important. Think that, yeah. And again, like regarding the question which what projects and collaboration, that's, I would say that's a bit vague. So if you have if you want to work, so that's what I would just say. If you want to work in a company like where your interest is EV, you want to work in a company that builds EV, then choose projects within EV area. And again, within electric vehicle is a very complex part. If you just break down the electric vehicle, you have battery management system, you have power electronics, you have motors. So you cannot build a project in like in the final semester on all those things. So choose a section out of it, then use tools like software and MATLAB to see like particular behavior. Maybe I can sort of help you out also if you have a particular theme on what you want to work on. If that helps it, then I think I'll have a question from Ethan saying that as an upcoming second year electrical and electronics engineering student, how should I approach hands-on project, and what type of projects should I focus on building a strong foundation in my field? So again, when you work on hands-on project, like I said, one of the challenges, so let me just go to the slide if I'm still, I hope I'm still proceeding, right? Uh, could someone confirm if I'm, yeah, perfect. So just to give Ethan your point, like if you look at a hands-on project on the left, that's a solar panel, which is a hands-on project. But there's a, you could do that if it's not a main. I mean, again, my recommendation, I would say if you want to build something like this, build during something like MEC labs. I mean, not just a simple solar panel, but actually show such physical demo. So you have some projects when you sort of demonstrate in MEC labs and stuff like that. There could be competitions also where you could introduce that sort of hands-on innovation to showcase, be part of that competition. Maybe like you develop some sort of methodology where you are improving something and you have some sort of a prototype, that's good. But when it comes to main project, the main interesting part, like you said, if you want to have a strong foundation, you will have to run different test cases. So you can, if you build a project like what you see on my left hand side, you have a prototype already. You cannot just change the battery and then just put a different thing. You cannot keep doing that. And that's what exactly, where exactly tools like MATLAB or similar softwares helps you. So you can build a similar model in MATLAB, change the battery, like in MATLAB, it's just changing the numbers, and you learn on your own, like how this behavior is happening, what is happening when I change the battery capacity, what is happening to the grid when the solar, the sun radiations is low, or when a fault is happening. We would have heard, right, like today there's a power cut or that's a very common thing that we say in Kerala, like there's a power cut here. Have you ever thought when the power goes, what is happening on the other side? it, you could actually build a model like what you see here and see when a grid, when a generator is lost, what is happening? How does a solar plant or something behave? This will give you strong knowledge to understand. And this also sort of answers many people's question like, why can't we have a lot of solar? Why can't we have a lot of wind? Why can't we have like 100% renewable grid? You will get an answer. And the answer is it's not possible with the current technology. You simply cannot have it. And the reason for that is our power system is very vulnerable. And solar and wind or any other forms of renewable energy, they are not as good as fossil fuel based generators. So that is a challenge. So I think regarding Ethan's question, like you can do hands-on project, and I'm not saying in a main project you should not do hands-on, but when you choose a hands-on project, choose something that is application oriented. Just do not make like 4 solar panel and then just conclude that okay, we use solar panel and hey, I'm able to light a CFL or an LED bulb. No, that is not an engineering study. But I'm not saying do not do it. That's completely up to you. But for me, that is not an engineering study. That is not enough. I would want to know, okay, what happens if you instead of 4, what happens? What is the impact of putting 12 panels? How much bulb can you? So to do that, you need simulation. You would need some sort of electrical model that you build, and you will understand what is the impact. And as you can see in my screen, you will be able to build beautiful graphs, which is part of the engineering style. We say that when you have like 4 panels, this is the load that I can support. When you have 20 such panels, this is the load. When you have 100 such panels, different things. So these are the studies that will come out of such projects, and you will, without even, I mean, automatically with these simulations, with these assessments, you will slowly start developing foundation knowledge. And second thing, read a lot. Read as much as you can. Follow in LinkedIn. Get to know what is happening across the world of power systems and similar things. There are a lot of people like if you can connect me in LinkedIn, you will get to know like I do follow a lot of things in the field of EVs, power systems. So get to know what is happening, and maybe something is that you could be able to connect something in your project as well. Hope that answers your question, Ethan. But yeah, feel free to reach out to me in LinkedIn also if you want to know more. And Namish, I think I had one more question, which was something very similar, like what all skills are required for a triple S5 student to get a place in a good company. But that's very similar to what I explained to the question which Ethan had asked and also what Namish had put before. So engineering skill set kind of showcase, like I said, CV shall represent what you are. If you have some achievements like be it let it be arts, volleyball, sports, excel, EMF, or conducting events, industry visit, those are certain achievements, certain that shows your traits that you are good at something. And final thing, the project which displays your engineering knowledge within 4 years, what you have accumulated, what software you have used, what have you concluded as an engineer. So these things will ensure that you have a strong I'm saying strong foundation from a BTech, a graduate perspective. As someone who learned 4 years of engineering, and this forms your base to understand. And when you step more, so you will get to know that when you start actually working in, like when you reach where I am working, you get to know that what you build in MATLAB, what you see here is like a very simple thing. It's far complex than what you think, but this is a good start. To start simple, to start the basics, this is a good start. And then when you slowly start working on projects like I just at the beginning of the slides I said, right, like there are massive projects coming in within the field of renewables. There are massive EV projects coming in India. There are new charging stations projects coming in India. So it's a huge charging projects are coming in. So who is going to build these things? It's basically you people are the one who are going to build it in the future. So when those time comes, be ready. And when to be ready? Right now. Start things, start learning, and slowly start building your knowledge towards it. Eventually you will start building. I mean, you have to work in these companies, in these projects. It's basically your responsibility as an electrical engineer to work on it. So feel that pride, have that pride that you are doing something which no other branch of engineering can do. That is the most important thing here. No other branch in engineering can make something that is very crucial, and that's the beauty of electrical engineering. So have that. I will also do one thing. I'll just share the slides, and I have a request. Like if people are connecting, I would request connect me through LinkedIn. Let's try to keep it in a professional way, because tomorrow, like within, you'll be graduates, and LinkedIn is the professional platform where people communicate, and it's important that you connect through me in LinkedIn to get to know what is happening. So you may get new topics, new themes, to get an idea what's happening in the world outside. So let's try to be professional. I think I'll just share the slide where you'll also find my LinkedIn URL. Connect me through it, and if you do have a questions, reach me out. Let me see what is the best way I can help you. That's something that I can do. If you don't have any questions right now, or if you are kind of reluctant to ask, that's also absolutely fine. Connect me through LinkedIn. Let's reach out then. Yeah, yeah, I'm good with it. Yeah, thank you. I'll also take leave. Or do you want me to stay 5 minutes, Ramesh? Okay, yeah. Thank you. Thank you all for this time.
I don't think he's dead. Hey, I don't think he's dead. Hmm?
Oh my god.
Did you guys say your blood pressure? Because you have to keep monitoring.